Hello, good afternoon, everyone. Today it's my pleasure to present my work here. I'm from Chinese Academy of Sciences. My work is about a deep learning-based framework for intersectional traffic simulation. As we all know, traffic simulation has been widely used in some fields such as city planning and traffic forecasting, especially for VR games or movies. It contributes to providing immersive vision and feeling. On the other hand, autonomous driving is a hot topic now, and traffic simulation also can build a realistic simulation system for autonomous driving tests. There are some works about traffic simulation. As shown in the figures or video, most of existing traffic simulation works have been focused more on simulating vehicles on freeways or city-scale urban networks. However, little research has been done to simulate realistic intersectional traffic, or some works are based on some simplified assumptions. For instance, in some well-known work or traffic simulators, the simulation or intersectional traffic is oversimplified, and some vehicles drive along predefined lanes and follow car-flowing rules, which is not suitable to common sense. Compared to the ground truth intersectional traffic shown in the video, the simulated trajectories are too regular and lacking of flexibility. So let's have a look about the vehicles in intersections. Intersectional traffic simulation often need to handle heterogeneous vehicles mixed with pedestrians, and the interactions among different agents include vehicle-vehicle interactions and vehicle-human interactions. If we use the trajectory prediction method in crowded space to plan trajectories for vehicles, each vehicle is treated as a particle without kinematics in the model. And the intersectional traffic simulation involves more dynamic environment factors. Due to the lacking of clearly defined lanes, vehicles in intersectional traffic have more flexible trajectories than those vehicles on freeways. So, inspired by the above insight, in our work, we propose a novel deep learning-based framework to simulate intersectional traffic. A new data representation tailored for deep learning is introduced to encode heterogeneous vehicles mixed with pedestrians in intersections. And we also introduce a new user editing technique to effectively edit the specific vehicles in intersections. Our method consists of three main parts. We first construct a high-quality intersectional traffic dataset. At the first stage, we process the data and convert it into a compact yet effective representation for deep learning. It includes the introduction of a grid map to encode the dynamic intersectional environment and vehicle interactions. Then we employ the combination of CNN and RNN to learn the velocities of vehicle trajectories. After that, we adopted the geometric method to calculate the orientations based on the predicted path. Different from the vehicles driving along the predefined lines, those vehicles passing through intersections are influenced by the current driving environment and its driving purpose. So we use the environment matrix and vehicle identity to describe this information. The vehicles passing through an intersection rely on the visual perception of the vehicle traffic agents in the neighborhood, such as their velocities and positions. Inspired by the concept of the visual depth maps and the characteristics of vehicle environment interactions, we introduced the grid map to encode the interactions among different vehicles. As shown in the figure on the left, we build an environment matrix to describe the driving environment around a vehicle based on the grid map. Each environment matrix has 5 channels. The grid scale of a grid in each channel denotes the values of current grid. When a vehicle drives through an intersection, the destination of its trajectories is its location at the last step. For each vehicle, we use vehicle identity to represent the vehicle's driving information towards the destination. It includes the relationship between the positions and orientations of current vehicle with destination. Combine the environment matrix and vehicle identity, we can get the driving state of each vehicle at each step. We then use the velocity and orientation of the vehicles to represent its trajectory status. So the objective of our framework is to learn a mapping sequence-to-sequence function from the driving states to the vehicle trajectory status. We build a network consisting of CNN and RNN. The CNN is used to extract features from the environment matrix, and the RNN is designed to learn the velocities from the sequence data. At each time step, the CNN uses multiple convolution and max pooling onto the environment matrix from bottom to top. To the end, the environment matrix is transformed and reduced to an environment feature. Then, for a sequence of environment features and a sequence of vehicle identities, we can easily map 2 sequences and build a fully connected layer on top of it and output the velocities of vehicles. In this process, we also use a geometric method to calculate the orientations based on the predicted results. Then let's have a look about our simulation results. And our method can simulate various interactions among heterogeneous vehicles and pedestrians. By encoding various interactions within the local neighborhood of each vehicle, our method can avoid most collisions. Here we show 2 examples. We plot the trajectories and the velocities of the observed vehicle, and the different color means the different time step. In the figure on the left, there is a bus and a vehicle coming from the opposite direction. The observed vehicle will decelerate to avoid collisions with them for safe driving. The observed vehicle in figure on the right tries to drive into a group of pedestrians. It will also decelerate to avoid collisions with these humans, and then accelerate towards the destination. These 2 examples show that our simulated vehicles can effectively avoid some collisions with other vehicles or pedestrians. Our method can also edit the existing intersectional traffic by modifying some vehicles' trajectories, adding new vehicles, or deleting some existing vehicles. We call it traffic editing. So let's have a look about an example of vehicles which is given new destination, how it plans new trajectories for itself and neighboring vehicles. This is our traffic editing compared results with the ground truth. The highlight vehicles with red rectangles are our editing vehicles. Furthermore, by specifying the terrains of the intersection and the initial states of our vehicles, our method can also simulate traffic scenes with different terrains. This is also another application. Here we show 2 examples. In conclusion, in our work, we propose a novel deep learning-based framework to simulate intersectional traffic. A new data representation tailored for deep learning is introduced to encode the heterogeneous vehicles mixed with pedestrians in intersections. And we introduce a new user editing technique to effectively edit the specific vehicles in intersections. Thank you for your time. And do you have any questions?
So are there any questions? Yeah, go ahead, please.
Thank you. This is quite interesting. My question is about driving culture, because obviously if you consider different countries, like maybe driving on a German highway or driving in the UK or driving on some unnamed Eastern European country, their politeness, their kind of behavior will be quite different. So could your model be adapted so it can learn different driving cultures as well?
So let me repeat the question, okay? So your question is about in different countries, the behavior, driving periods will be different, so our method will apply to various countries, right?
Yeah.
Actually, our method is based on a deep learning framework. So we first construct a data set on the intersectional traffic in our country. But actually, our method is just a framework. If you provided more data set, I think our method can apply to more various intersections.
Right, brilliant, thank you.
Any further questions? So I have one. So did you look into how persons being immersed in such environments behave, or whether they perceive that as a very natural kind of simulation of traffic? So do you have any results on this?
So any results about the nature?
Yeah, so how persons perceive the simulated traffic when they are immersed in VR, because you presented these bird's eye view perspectives, but I was just interested in how people perceive that when they're really standing at this intersection and see the traffic flowing.
Actually, this work is only the first step in our work, and this work mainly focuses more on trajectories of vehicles in intersections. But in the future work, we will just improve the interactions between pedestrians and vehicles to improve the perception of pedestrians.
Okay, good. Thank you very much. Thanks. The presenter again, please. So the next presentation will be also the